solve the system. 11x plus 3y equals 27. 8x plus 4y equals 36 using the elimination method or addition. So we're going to go ahead and try and add these two equations together and get either the x's or the y's to cancel out. Now, if we just added them directly, we're not going to get anything to cancel out. So what we're going to have to do is we're going to have to find an appropriate multiple to multiply one or both of these equations by so that we do get some cancellation when we do the addition. Before we go ahead and find that multiple, I'd like to make this problem a little bit easier. These are all pretty big numbers, but I notice that in this second equation, 8, 4, and 36 all have a common multiple. They're all multiples of 4. So we could go ahead and rewrite this second equation by dividing each piece by 4, and we'll have a little bit smaller numbers to work with. 8x divided by 4 gives us a 2x. 4y divided by 4 gives us a y. 36 divided by 4 gives us a 9. And now our second equation is a little bit nicer to work with. We can't do anything similar with our first equation. 27 and 3 are both multiples of 3, but 11 isn't, and 11's not a factor of 3 or of 27. So we can't do anything to make that first equation a little bit easier to work with, but now we have a new system of equations. This is equivalent to the original two, and this equation's a little bit nicer to work with. Looking at this, we notice that we have a 3y and we have just a single occurrence of y here. If we were to go ahead and multiply this by a negative 3, then 3y and a negative 3y would cancel when we do the addition. So let's do that. Let's multiply both sides of this equation here by a negative 3. So when we do that, negative 3 times 2x is a negative 6x. Negative 3 times y is a negative 3y. 9 times a negative 3 is a negative 27. Now we can go ahead and add this equation to the other equation. Let me rewrite that other equation right here. 11x plus 3y equals 27. And let's do the addition. Negative 6x plus positive 11x gives us 5x. Negative 3y plus 3y gives us 0 y's. We can just ignore that. 0 times y is 0. Negative 27 plus positive 27 is 0. So we have 5x equals 0. Divide both sides by 5. We get x equals 0. Let's go ahead and discover what y value we need. We can do that with either this equation or this equation or this other version of that second equation. We have lots of options. Since it's the cleanest looking option, let's go ahead and take this first equation that I haven't scribbled all over. We'll just plug in our x value. 11 times x is 0, plus 3y equals 27. And we'll go ahead and solve for y. 11 times 0, of course, is 0. So we have 3y equals 27. Let's divide both sides by 3. We get y equals 27 divided by 3, or 9. So it looks like a solution to our equation is the ordered pair x equals 0, y equals 9.